Welcome, everyone. We are very excited to have you here today. This is our sixth Health Research from Home webinar. And today I'm going to be your host. I'm Rachel and the Strategic Partnership Leader for Health Research from Home. And today, together with Coral, we are going to be your hosts. And with that, let's start with some housekeeping items. We are going to record this meeting, and you will be able to access the recording on YouTube by the end of the week. We are pausing the recording during the Q&A session. You are very much encouraged to use the chat box if you need technical support from the host or to chat with each other. And we are very much welcoming questions in the question box. Today, we will have two fantastic speakers. So it's Soren Brage and Tomas Gonzales on body composition, fitness, and activity using smartphones and wearables. After the speakers, we will have a Q&A session for 10 minutes. Again, please put your questions in the Q&A box. We will prioritize the questions coming from the Q&A box. And then we will have an exciting guest, Lynn Laidlaw. Lynn is going to give us a live update from a research project we are executing as we speak. We are looking forward to her update. And then I will close this webinar with some upcoming events. Many of you who are joining us soon, we will be excited to hear that we are on track with all of our upcoming events. So with that, I am going to pass it to Soren. And please welcome Soren Brage with Physical Activity and Epidemiology Program Lead from the MRC Epidemiology Unit from the University of Cambridge. And then following Soren, you will have Tomas, Research Associate in the Physical Activity Epidemiology Program, University of Cambridge. I stop sharing now and I pass it to you, Soren.
Thank you very much, Rachel. So let me just find my slides. Right. Can you see that?
Yes.
Is it still showing the notes?
Yes.
Yeah.
It is. Okay. So there's it. Right. How's that?
Perfect.
Perfect.
Very good. Okay. So Thomas and I, he's sitting, we're working in the same room, of course. We're sitting in the same room, but we'll be sliding in and out of you, hopefully for a seamless transition. So what we're going to talk about today is on the outline here. We're going to talk about body composition, cardiorespiratory fitness, and physical activity, and with a particular emphasis on whether we can measure these things now from home using the technology that is now available. So let's jump straight into it. We might reflect on why we do this in the first place. And actually, a lot of this is the voice of our research participants when they come and take part in our classic studies, because often they will have clicked onto the fact that, hang on a minute, couldn't I have done this at home? So there's a real appetite for doing a lot of the research that traditionally we would have done in the clinic from home. And certainly people know that their devices know a lot about them. There are also some concerns about how much they know about them and particularly in terms of privacy. That bottom one there probably doesn't make that much sense to you to begin with. So, but it will in the next couple of slides, I hope. So let's start with body composition. So can we measure that at home is the question. How we would do that now is we would essentially use medical imaging if we want to measure things really well. So those are very precise direct measures, either MRI, CT, or DEXA scanning. But you can also buy devices that use impedance, or you can use even your trouser size or your weight and height to estimate how our bodies are composed of different tissues. So the question is whether we could do a little bit better than just looking up our trouser sizes for estimating body composition. And indeed we can. So the technologies that are now available allow a couple of images to be taken, a couple of photographs to be taken on smartphones, and then estimates of body shape, so a 3D model of the body to be computed on the phone, and then machine learning algorithms implemented on the phone can then estimate body composition. So for example, the percentage of body fat from those measurements. And the way that this research is typically done is that we use a DEXA silhouette to simulate the frontal image of those phone messages, and then we train the models. So this is what's shown here, and a very typical setup from a paper from last year, the sort of scatter plots between the predicted and the truth. But in this particular study, which had a longitudinal element, we were also able to evaluate the method's ability to detect change over 6 years. So this is change in DEXA measurements and how we would normally do medical imaging, and then this sort of imaging silhouette type of methods. And those are things that we could implement in smartphones. And indeed, there are several apps that now apply this type of technology or approach to give you estimates of body composition. But you can also see there that it's very important where those images are processed, and you don't want to necessarily be sharing those images outside of your phone. So the apps that are doing all of this processing on the phone, you can see that the concerns are less than those that are sending pictures over the web. Okay, and with that, I'm gonna transition over to Thomas for some fitness work.
Excellent. Thank you very much, Soren. Right, so for the next few slides, I'll be talking about cardiorespiratory fitness and several approaches that we could measure it in home environments. So when we talk about cardiorespiratory fitness, what do we really mean? Fitness can mean a lot of things to many different people, but here we're defining it as our body's capacity to utilize oxygen during maximal sustained physical activity. And the typical way that we measure fitness, or CRF, is maximal oxygen consumption, or VO2max, or in terms of metabolic equivalence, which is just a composite measure of energy expenditure. And one of the main reason why we want to look at fitness is that it's very highly associated with metabolic disease risk. The plot on the left shows the relationship between incident type 2 diabetes and fitness in UK Biobank from a recent study that we published. And you can see there that the relationship is quite strong. And the plot to the right shows the results of a meta-analysis done about 15 years ago, showing the relationship between fitness and cardiovascular disease risk. And combined, these both just show that fitness is a very important predictor of metabolic health. Now, the gold standard way that fitness is usually assessed is in the clinic using an instrumented metabolic cart. And this allows for the complete characterization of the physiological response to exercise. And this would use ECG to look at heart rate, respiratory gas exchange systems to look at differences in the volumes of expired oxygen and carbon dioxide as exercise progresses. And using all these, we can then infer what one's energy expenditure is while they exercise. And these are all typically controlled by an instrumented exercise machine, which could be a treadmill or a cycle ergometer, which is shown here in the picture. And these can be programmatically controlled in order to deliver a defined exercise dose. And through all these processes, we're able then to both accurately and reliably assess what one's VO2max is. The problem with this, however, is that it's quite costly, so we can't scale it, and generally not feasible in most home environments. So what we developed are several approaches that we could implement in home environments in order to assess fitness. and they're ordered here in ease of assessment, similar to the slide that Soren shows previously for body composition. So we'll just go in order here, talking about both stepping, walking, and then resting heart rate and passive monitoring. And the reason that we're showing these is that these could be implemented in such a way that they could adapt to the unique circumstances of individuals, depending on whether they're able to do certain modes of exercise or not. So for stepping, we've developed an 8-minute protocol that allows us to assess fitness via the protocol showed on the center plot there. First starts with 1 minute of stepping at a fixed cadence. The step could be either 2 centimeters or 1.5 centimeters. Then after 1 minute, the cadence increases in a linear fashion for 7 minutes. And then after that, there is a 1 minute rest period. And all the while, resting heart rate, heart rate would be monitored using either a smartphone or a chest-worn device. And what we want to do we have developed an approach that allow us to estimate fitness from their heart rate response during the exercise portion of the test, in addition to the recovery phase of the test as well. So depending on how high or low their heart rate goes up, or depending on how fast it takes their heart rate to return to their pre-exercise levels. And just as an application of how this was implemented in a home environment, this was previously used in the Health Survey for England in 2008, where a staff nurse of that study implemented that in participant homes. And the data shown on the right shows the distributions in older and younger men and women as a result of that work. It's important to note, however, that as a part of this work, they screened approximately 3,500 individuals for the test using the Rose Angina Questionnaire, which essentially just asks individuals if they've experienced chest pain in the past as a result of exercise. And more than half of the individuals actually ended up being screened out of performing that test. So this just kind of highlights, some of the considerations that go into place when we implement these sort of prescribed exercise bouts. But what if we had an alternative where we allowed individuals to exercise at their own pace? Could we infer fitness from that? Well, we've developed a 200-meter self-paced walk test in order to do that. The protocol is quite simple. We would just ask individuals to walk at a pace that's comfortable to them between 2 markers that are 20 meters apart, and they would complete 5 laps total of that. The heart rate response to that in the protocol design is shown in the plot to the top right here. And based on features that we would pull from those data, we're then able to estimate what their fitness is. And we've compared what the fitness estimate would be from the walk test to fitness estimated from a clinical treadmill test, similar to what was shown previously. And the plot on the bottom right shows there to be approximately very good agreement between treadmill-based and walk-based estimated VO2 max. Progressing further, we could also use resting heart rate as a proxy measure of fitness. So resting heart rate would typically be measured while you're at rest, either seated or supine. There'd be subtle differences in what the resting heart rate you would get between those two, but they're quite minimal. And this could be assessed either manually or with a heart rate monitor or with a smartphone. And we investigated the principle of this in the Finland study in approximately 12,000 participants, where we looked at change in resting heart rate over time versus change in fitness measured using a treadmill test over time. Follow-up time here was approximately, I think, a mean of 6 years. And we find that they are associated, change in both of those parameters are associated in both men and women. And extending this principle then to a remote monitoring situation, we implement this during the COVID pandemic, where we did remote monitoring over the course of the pandemic from August 2020 to May 2021, where we wanted to look at what the resting heart rate trajectories were in individuals when we stratified by their pre-pandemic fitness levels. And what we found was that And at the onset of the second national lockdown, those with lower fitness tended to have their resting heart rates increase with time relative with those mid and high fitness, which was an interesting observation and an interesting application of this principle as well. And finally, we could also just use wearables to assess fitness passively from the data that's collected on them. And this usually uses a data fusion approach where we take data such as accelerometry, resting heart rate measured as people go about their day, and then we use machine learning models to figure out ways to infer what one's fitness is as a result of changes in those over time. The plot in the center here shows a approach that we had developed that uses this in the Finland study. And this shows good agreement, and we were able to demonstrate good agreement between predicted VO2 max from the deep learning model that we developed and treadmill estimated VO2 max. And then the plot to the right just shows whether or not we were able to detect change in VO2 max over time using this approach as well, and we were able to demonstrate that as well. And if anyone was interested in looking at this model or this approach, we've provided source code, data samples, and trained models at the GitHub repository shown at the link here. Great. And so with that, I'm going to hand back to Soren to speak to you about physical activity.
Excellent. Thank you, Thomas. Sliding in here. So physical activity, obviously, unlike body composition and fitness, is a behavior, not a status variable. And it is also what we try and capture with our wearables, probably more so than fitness. But as Thomas just demonstrated, we can also derive fitness from that. So physical activity behavior is a more variable phenomenon, and typically would summarize that in different ways. For example, we could take the area under the curve and call that the total volume of physical activity, or we can slice up this time series here and summarize time spent at different intensity levels. So the question is whether we can capture the intensity time series well with technology that's available through everybody today. So what we could do is we could repeat one of those exercise tests that Thomas just talked about, and then combine it with long-term heart rate monitoring that effectively enables you to translate your heart rate monitor values of beats per minute into, for example, energy expenditure. So that we would call the FIC principle. So that has a very long history and based on very strong physiological understanding. And we could then validate that in various sort of laboratory settings to check if we're getting reasonable estimates of energy expenditure if we compare it against directly measured. So that's the red curve in this slide here across different activities. And we're comparing against the gray criterion measure. The other way of doing that is we attach accelerometers to people close to the center of mass, and then we use a Newtonian first principle model to estimate what the energy expenditure from activity might be. That's the black line that you see on this graph here. Or the third would be the obvious combination of the two if you were lucky enough to have a combined sensor, which many wearables now do. And that would be the blue line here. So that's just a lab study. That's kind of not really that relevant because you can design these any way you like and get any result you like. Where it really matters is when you put it to the test of free living. So put these monitors in free living and compare it against the gold standard in free living. Measure that with stable isotopes, and we compare the area under that intensity curve against what the isotope measurement is. And this is what this shows. So these are Bland-Ullmann plots, and you want all the dots to be close to the zero error line. So you can see that if you're using an individually calibrated model like the FIC principle with exercise test combination, that's the top left plot there. then you actually get reasonably good agreement. So that first principle approach of using heart rate monitoring, it does work. It has some scatter. If you're using the Newtonian approach, you don't need to individually calibrate that. It's a different variance. Then actually also getting a reasonable agreement for that. But there are some individuals that do activities that are difficult to capture with your single accelerometer attached to the center of mass. And then the combination of the two do even better, has zero mean bias as well, and less scatter altogether. So most wearables that people will buy today do not sit close to the center of mass, which is sort of behind your rib cage, more or less, in most sort of positions. They sit on the wrist. So then the question is, well, how does wrist movement compare to these other methods of capturing physical activity intensity? And this is a couple of different studies that are linking validation or method comparisons in different validation studies together. So on the right, you see a comparison of wrist, non-dominant wrist acceleration against this combined sensing estimate. Then on the top right, you see a comparison between non-dominant and dominant wrist acceleration, different study. And then you put those two together and compare it again against a new study of isotope measurements. And we check that it works. And you can see that the observations are distributed around the zero mean error there. So no mean bias. So why is that important? Well, that's important for research studies for sure. This is an example for UK Biobank from a recent paper showing physical activity energy expenditure estimated with this approach and the risk of developing diabetes over time. And as you can see here, the dose response curves are really steep. So they are really strong relationship, emphasizing that physical activity behavior are certainly very important for our health and future disease risk. So the question then is, well, surely, of course, UK Biobank was a research study. It used standardized accelerometers to measure this, this wrist acceleration. Could we have used people's own wearables to do that? Well, the metric used from that accelerometer was actually very simple. So if we could convince all device manufacturers to produce that metric in their watches, then that would be one approach. I would say that's probably too good to hope for. So we might need a different approach and have to accept maybe what these wearables give us. And the problem with that, of course, is it's a bit of a Wild West. So there are so many different metrics that these different consumer wearables are producing that we could end up with worse research, although in more people, than we were if we were just using the research grades, standardized studies. But there is a solution. So we need to work on methods that harmonize the data between different measurements. So this is effectively mapping between the measurements of activity on your phone or your wearable to some of the research grade methods that have been well studied so far in the literature. So this sort of intermapping is sort of depicted here. And we can then expand that to just basically link everything with everything and keep going forever until we got something that we already know the relationship with the target variable of. So you can think a little bit, you can think of this a little bit like the London Tube map. If you start at one station that would represent your one specific wearable and you want to get to another station, you might have to go through a couple of other lines on the tube map, and you jump basically, as long as there's a link, you jump through this network until you get to your target destination. So it's a little bit like that, and obviously that's a big job. So we're going to stick all of this stuff that we have developed and hopefully others would like to contribute to on the measurement toolkit. The URL is shown there. That's a free site where you can make contributions to the research community. And hopefully this will grow over time and people can map their measurements to what they need. Right, so finally, we would just like to remind ourselves, why are we all doing this? Well, one of the reasons why we're doing research is we were hoping for a better world, and we're hoping to support people live healthier lives. So I'm just going to show you an evaluation of the NHS endorsed walking app. It's called Active 10. It's encouraging people to walk more. This is an evaluation in about 200,000 individuals that took part in this. It's got various components. I won't have time to go into that, but you can check their website. And here's the evaluation of the first month post download of this particular app. So this is not like a trial because it doesn't have a control group, but it is an intervention because there is a manipulation of a kind of the sort of interruption of the time series here. So before the dotted line is the base, is the data that's pulled into the app from the historical data stored on the phone. And after the dotted line is the activity or the steps taken after the engagement with the NHS walking app. And you can see that it does jump up, maybe not by much, but at least it goes in the right direction. And anything is better than nothing. And it does that both for the primary target, which is brisk walking in this app, but actually also for non-brisk walking. So it's not like you're just swapping different kinds of walking and then it doesn't change. But of course, we're not capturing other types of activity. So it is possible that overall activity maybe didn't change. But nonetheless, this is an example of maybe this helped some people on that journey to increase their activity levels ever so slightly. Okay, so with that, we're going to thank you for your attention. And
wonderful. Well, thank you, Soren. Thank you, Thomas. Great presentation and lots of food for thought for the audience. Thank you. So one of the things that we do in Health Research from Home is that we're running 2 projects that are trying to understand how we link digital patient-generated data with other data sources, including NHS data. Lynn's going to give us an update about one of the 2 projects that we're running and how we're involving patients and the public in designing the process to actively recruit and set people up as participants in this study. So Lynn, over to you.
Thanks, Will. Right, I'm going to attempt to share. Here we are. Right, okay. Thanks, everyone. So my name is Lynn Laidlaw, and I'm the patient and public co-investigator for Health Research from Home. And I co-lead the patient and public involvement, which I'm going to call PPIE throughout, with Dr. Charlotte Sharp. And part of our remit is to meaningfully involve patients and the public in smartphone and wearable research as an integral part of the team and just kind of like business as normal. So I'm going to tell you today about some of the PPIE work we've done for Paprika, which is one of our driver projects. So what is Paprika? So just a quick run through what it is. So we want to look at how active people are before and after knee replacement surgery. We're looking for people to take part who have tracked their physical activity using a smartphone or a wearable before and after. They need to give us consent to access their patient record on the joint registry. And sign up to the study will be via a dedicated website where people can access the participant information sheet and upload their smartphone and wearables data. So I just wanted to go over, well, what is PPIE? Some people on the call might know. So it's doing research with people, not for them or to them. It's mandated by many funders, including the NIHR in the UK. And we needed to understand if the recruitment website was easy to access and understandable. Would it make sense to the people who were going to participate? And also PPIE ensures that the research is relevant to the people affected. So what did we do? So we put out an advert on the People in Research website, including some details about what it is we wanted to do, and also what experience that we felt people needed to become involved. We asked people to tell us briefly why they would like to be involved. And we tried to get a mix of characteristics, for example, gender, ethnic group, etc. But that's challenging when we were only involving 6 people. And I think a really important point here is that PPIE is often conflated with participation in research. So it certainly needs to be diverse and inclusive, but public contributors can't be held to be representative. So preparation and planning is key, and these are some of the things that we did in advance. So we created a PowerPoint presentation about the website, showing the people that we involved, all the steps that participants would need to complete. We wrote an explainer about the project, which we sent to people in advance. And we also, as a team, had multiple team meetings in advance of the workshop so that we understood what our roles and responsibilities were and what we wanted to get out of this. And we also took the planning to the kind of degree, and so I wrote a script to ensure that we covered everything in the workshop and just asked people all the questions that we wanted answers. So what feedback, what did we learn as a result of the workshop? So that accessibility is really important, and that included the colour of font on the website. We really want to put a couple of explainer videos on our website to sign people up, and that was an excellent idea, but they needed to be short and have subtitles. There was a suggestion that even if people couldn't participate in Paprika, that we could link to other opportunities for them to participate in other research. And also, people that we involved told us we needed to be clearer about what data we are collecting about people. So when you talk about health records, was that all their health records, when actually all we were wanting to do was access information about their joint replacement? So that was really important for informed consent. And just our wording needed to be clearer on different parts of the website. So people so that potential participants had a better understanding of what was proposed. We needed to make it clearer that participants needed to have tracked their activity both pre and post-surgery. We received loads of helpful suggestions about different ways to recruit people when we opened to recruitment. We needed to make it clearer how participants could withdraw from the research, and also make it clear that we weren't collecting or going on to collect real-time data from the fitness trackers. This was stuff that had already been done. We needed to explain better what anonymised data is and what data we'd collect. And also, we needed to have a very clear and transparent cookies wording, but in language that was understandable to people, not just what the institutions said we needed to do. And follow-up is really important, and people that you involve in your research should have power over how we use their insights. So we had permission from people to record this meeting, which turned out to be really important. And I wrote extensive notes and also detailed the actions arising from the conversations that we had. And this was then sent to everyone who'd been involved for their comments and edits. And we remunerated people for their time, both to attend the workshop and for reading and commenting on the document. And this is really important because you know what? Public partners to research aren't a free good. If you value your time, then you need to offer them payment for it. And finally, I just wanted to share some reflections. So planning is essential. Patient-public involvement, to do it well, requires time and resources, and you need to commit the time and resources. As I said, it's important to feed back to the people involved and to be clear about how you have used their insights, because otherwise, why would people get involved if what they told us just kind of disappeared into the ether? And you also need to be clear about what the involvement opportunity is. the time that people will need to commit, and the payment that you're offering. And finally, you know, patient-public involvement is essentially about relationships. It's about communication. It's about collaboration. And although you can use methods to do this, it's more than a method. And this workshop was just the first. We're going on to hold another couple of workshops with people once the recruitment platform is finished, because we want to be sure that when we make this recruitment platform live, that it actually does what we think it is, that it's accessible, and that people can participate in a way that's not onerous and doesn't require too much of them. And I'm going to stop there. Thank you.
Thank you, Lynn. I'll just give people a moment to drop any questions in the chat if they have them. I mean, my experience of this is that it's so vital to do health research from home, to have patients and the public contributing their data. It's really important that everything to them is clear about what it is that we're trying to do, why we're trying to do it, that it's easy to do, as easy as possible. And in the Paprika study, it's going to be really difficult. So we have to work very, very closely with our PPI groups to get it right. And we'd encourage everyone to do that themselves in the future too. And we hope that we can help support people in doing that in the future. Soren, Thomas, you have your hand up, and then we'll move to...
Just a comment on that sort of columns of importance, and also that when people are willing to share potentially sensitive information with us, that we can reassure them that we're going to look after their data and put it to best use without exposing them. That element of trust is even more important than when we are doing classic research, because it's a lot riskier to do this type of research in terms of compromising privacy if we don't get it right. That's very easy to do for medical research, right? We have our procedures. People are always anonymized in terms of our data sets. It is really important that people don't lose trust in us as researchers.
Thanks, Soren. Rachel, over to you for the last few minutes.
Welcome, everyone, again. As I promised at the very beginning, I want to just bring a couple of amazing events to your attention. And the very first one, you might be very well aware that we have a fantastic live event coming up on the 7th of February at the Google headquarters in London, with some amazing speakers, a research showcase where the latest and greatest research project will be presented, and a technology showcase with U-Motive Aura radar base coming along to the event, so you can actually talk with them. So it's a fantastic event. It's fully booked now, but you should know about it, and if you've registered, definitely come along. We are looking forward to see you. The upcoming webinars. So the webinar series continues in 2025. The next one is in March, and then in May, and then every other month, all the way in 2025. Starting with John Ainsworth, Professor of Health Informatics from the University of Manchester, presenting on digital phenotyping in mental health. And then on the 7th of May, we will have Nardem Sarwal and Scott Small from Novo Nordisk, presenting on the Transformational Prevention Unit mission. So these are definitely fantastic topics and worthwhile to come along. And an important topic to share with you is our IG clinics. These are a unique opportunity for you to discuss your research project with an expert. You can book a 1 hour long session and explore what are the information governance considerations you have to think through specifically to your research project. You can book this session via the link in your confirmation email for the webinar. So with that, I want to give you a couple of QR codes where you can find further resources. And as always, we would love to hear from you what's interesting for you, what is useful for you, and you will see a poll popping up on your screen soon. And there you will have the opportunity to suggest topics for further webinars and speakers. Now with that, I want to say a big thank you to Soren and also Thomas and Lynn. It was a fantastic session, even though I missed a little bit, but it was truly a pleasure to host you today. And we are looking forward to see you live and at our next webinars.